So this is some research we're doing currently, and it's research involving one of my close collaborators, Dr. Nick Carra, who's also over at University of Queensland, and also a research assistant of ours, Adam Smith, who's an IT student and is doing a lot of work in my lab at the moment. So we work jointly between the School of Communication and Arts and the School of IT over at UQ. So this project, it's an emerging project we're kind of been developing for the last couple of years. And it kind of stems from some work that Nick has been doing in what he calls brand machines. And I'll get to this and talk about this initially. And also some work that the two of us have started to do, which is kind of this intersection between critical cultural studies and computer science. So we're bridging these two spaces together. So you're coming at it. So Nick is very much my rough equivalent, right? So he's also kind of a mid-30s hipster but he's coming much from the kind of cultural studies end. And my background is computer science. I've been a computer scientist for 15 years or so, and have done a lot of work in that kind of machine learning optimization space. So we're doing some work in this around what we call algorithmic brand culture. So that's what I'm going to start out, is trying to give a picture of this. And I will put a shout out there to Social Reaper, which is one of the products or projects that's really kind of at the grassroots of this project, about how we collect and scrape social media data and begin to analyze that and make sense of it. So let me start with music festivals. So Nick is incredibly interested, and I am now by extension, because I've kind of latched onto his research, really interested in music festivals, because music festivals are these interesting spaces, particularly in Australia, where it's seen that a lot of cultural influences hang out. Music festivals are a hotbed for creativity, for youth and youth culture to be expressed. And they're a space these days where brands are particularly heavily involved. So if you think about big music festivals in Australia, things like Splendour in the Grass and others, these are these kinds of hotbeds of creativity, music, all those kinds of experiences, those formative years where things are kind of happening. And so these pictures kind of give a glimpse of some of this in its early days, right, with brands experimenting in these music spaces. So what we have here is a music festival where Duracell had the rights to the water distribution, and this gigantic battery-looking device. It's actually a water tank. So yeah, the connection there, is so good, right? Filling up your water bottle from a battery. This space here by Virgin Mobile was where you could actually go inside one of these kind of sound booths in order to make a phone call in a very otherwise noisy, chaotic space of a music festival. Problem was there wasn't enough mobile coverage at the event itself. And so the utility of this was a bit poor. And same with this kind of, you could run through this tent and get sprayed with water as this like kind of V-can. These things kind of lacked a certain level of development panache, I guess. But fast forward a few years from this, and now this is kind of the more recent experience of festivals. And Amy Catt does a lot of this work in going and photographing and documenting these kinds of more recent and modern experiences of outdoor and nightlife spaces. And very much embedded in that now is this idea of like the whole kind of mobile and social mobile culture of lived experience. And so we're not just at a gig these days, we're at a gig sending photos, taking samples and sharing and spreading that experience outside the boundaries of the live music hall or the festival itself. And so festivals, through their development, started to embrace this, right? And so we see here, this is a festival where they started to embed this, and this is by kind of the old dumb phones, right? Like before we had smartphones and before kind of the iPhone changed everything. This is via MMS, right? That you would actually spend $2 to send an MMS on most carriers back in the day to get your photo up on one of these big screens. And so, these festivals have been experimenting with this kind of participatory audience connection for quite some time, but obviously with branding and other things attached to it. So fast forward to more recent experiences. So at a music festival like Splendour in the Grass here, these kinds of disclaimers and signs are now fairly commonplace. Things that say things like your entry beyond this point constitutes your consent to your likeness to be used for Virgin Mobile promotional purposes anywhere in the world at any time without litigation. Or a more friendly version, smile, you're on camera, filming in progress. By entering this area, I understand that I may appear on camera and my image or voice may be used for advertising and or trade purposes. That statement was posted in front of one of these large kind of pop-up bars that appear at things like Splendor in the Grass. If you've been to Splendor or you've seen these, they're things like, the Jägermeister have this kind of faux hunting lodge that they create and craft where you can go in and be immersed in this kind of experiential thing where it feels like you're in some kind of authentic hunting lodge. These are the kinds of places where brands are positioning themselves more as an experience than just as kind of slapping their logo on the side of the festival itself. And so what we're interested in is when these brands and cultural spaces become enmeshed, how this then kind of spreads out into the rest of the world via social media. And so, with things like Splendor in the Grass, there are a number of elements of Splendor itself and the experience which themselves could be talked about as like Instagrammable, right? The idea of, things and experiences lending themselves to the photography and then spread via social media mechanisms. So I'll give a few examples of this here. And so these are some of the classic, and these are all taken from feeds, Instagram images taken at Splendor in the Grass. And what you see are things like the classic Splendor in the Grass signage up on the hill itself, the subject of a lot of photographs where people take this and kind of share it on social media. We see down here on the bottom right corner, this is a barn raising that they staged. So they had people dressed as Amish and they raised a barn, and that barn was then later used by a brand as like a rum springer. So rum springer is where the Amish youth leave the Amish community and go and actually enter the kind of, I guess, the rest of the wide world and often get very drunk and, experience a lot of debauchery and such, and then they'll return to their community. And so this was actually a rum bar after it was an Amish barn. But yeah, this happened over multiple days. They did this kind of Amish barn raising. The Strongbow ship is like an antique sailing ship that's dumped right in the middle of the cultural precinct and festival space itself, and people can buy Strongbow cider and drink it. It is actually right in the middle of the actual like kind of soundstage area, so you can actually watch your band while standing on the deck of this kind of antique sailing ship, and other things like the shark and such are part of this. So when Nick was talking with one of his informants, who was a youth who was at the festival, and about their experience. So Nick does a lot of this where he will actually go out, speak with people who are at these festivals or in these nightlife precincts and get their kind of perspective on this. And this is kind of their point on one of these was there's this other one called Quench Your Curiosities. I think that might be Bundaberg. They had hammocks suspended, and so we went there as well, and but everyone was taking photos there of friends lying in the hammocks. Right, so this idea of even people themselves reflecting on that everyone's there just taking photos, right? Like everyone's lying in these hammocks just taking photos of themselves. And so this is part of this this new cultural process, right? This is a new kind of practice that's emerged post the social mobile revolution. So we can kind of conceptualize then branding as an open-ended cultural process. So branding is enmeshed in this, right? It's no longer separate. It's very much part of this fabric and tapestry of the kind of this cultural and music and nightlife experience. We think and conceptualize media platforms now, so your Instagrams, Facebooks, and others, as these kinds of brand-funded engineering projects. Brands are the bankrollers of a lot of what we use of social media, right? We don't, as users of social media, pay money. We are ourselves the product of their platform. It's the brands themselves that are investing in to get their messages, to get their advertising targeted at their users. And with this money, these media organizations, these platforms have spent a lot of money employing people like me, right, to turbocharge their platforms. These are massive open-ended engineering projects. When Facebook started, it was, I guess, tiny, right? It was running on a single server. Now it's ginormous and employs thousands of engineers to keep this running and to re-engineer it constantly. Media is now, I guess, is participatory and part of this data processing machinery, right? So the media objects we're seeing here are part of the machinery of this mechanism, right? That the images that we're creating are fodder for the machines of social media to work over and process. And so brands have shifted from controlling specific representations of their brand to now managing this meaning making more generally. So what this means is that the idea that brands are no longer just these kinds of billboards and things that you see, or things that you see on the side of a bottle or something like that, they're engineering and involved in the cultural space itself. Right, so they've shifted outside of that kind of being passive to being very active in creating meaning about their own brand and its values to its consumers. So as Patricia Clough puts it, the function of media as a socializing ideological mechanism has become secondary to its continuous modulation, variation, and intensification of effective response in real time. What that actually means is that brands are interested in the effective response of the participant. They're not just interested in passive kind of broadcast. They want you to feel good about their product. They want to be there in your face kind of and part of that cultural experience. They want you to go out and be part of what they create as an experience. We still do, as users, symbolic work of watching, of listening, of passive kind of consumption, but we're far more active than we have ever been in the creation of value for brands, right? So our body and such is affected by this shift in terms of brands and their configuration. All right, so where do we bring algorithms into this? So the idea of algorithmic brand culture is this kind of interplay between, I guess, the creative practices of users, the way, and brands themselves. So the way that brands are creating these kinds of experiences and such for people to experience and share, but then how platforms themselves can operate on this information, can read it, can datafy it, and then can use it as fodder for further kind of, I guess, intrusions or incursions into that cultural space. And so the effective labor in an algorithmic brand culture is how we ourselves are also training those machines. So it's our data that we're creating that's being used to train this apparatus. This whole algorithmic brand machine can't exist without us actually there actively training it. So why music festivals? Well, these are incubators or hothouses for this kind of activity, right? These kinds of experiences. Now, these are some of the prototypical examples of these kinds of brand activations and experiences, but you'll kind of see this, you'll see this elsewhere as well. You'll see this happening out, say, in the kind of King George Square, or you'll see it happening around Brisbane, in other places, in nightclubs, in other kinds of locales. You'll see all of this kind of activity happening where you're actually getting brands kind of trying to do this, trying to build these kinds of experience. So another example of this is a Smirnoff Black House, which is a house which is filled with black objects where people can enter, take photographs, share those photographs and those experiences outwards. So this kind of thing is happening more and more, and you'll see it now, right? I guess if you haven't seen this already, you'll begin to see these next time you venture out into a cultural space, settings like the forecourt of South Bank. You'll see brands trying to engineer these particular experiences. All right, so some examples. So that's the barn raising there at Splendor, the whale, this amazing kind of art exhibit. But the point of a lot of these images is to lead into the next section, I guess, which is with a lot of these images, they themselves contain objects which are recognizable. So Sky Whale here is a recognizable art installation. If you see that in an image, if you know this artist, you know this art, you will recognize it, right? And that's the point. If we as humans can recognize these artifacts, we can train machines to do the same thing. All right, so yeah, just one last kind of reflection on people's perception and perspective of this, right? This person liking Strongbow because it spoke to the old Splendor. You're just on a deck drinking a bit of cider, right? yeah, it's really interesting how people respond to these, right? These are brands, these are completely artificial experiences being created for them, but they do feel a connection to it. All right, so how do we convert this kind of shared sociality into machine classifiable data? How does this begin? So these objects kind of address the algorithmic decision making of media machines, and I'll show you how. So we took 1,644 images that have been taken over a 24-hour period. This is just from public feeds on Instagram using the Splendor in the Grass hashtag. There would be orders of magnitude more images taken at Splendor in the Grass, shared without that hashtag, shared on behind private Instagram profiles, in other kinds of messaging applications. So this is a paltry amount of images compared to the massive trove of images that would have actually been created at this site. But of that, we did this process manually first, looked through those images. We reckon that about 3/4 of them are posted by ordinary attendees, just people like you or me, I guess, right? Just there as participants at the festival. The rest were posted by identified social influencers and brands. But the actual number of likes, the share of attention, I guess, flips the other way. So 3/4 of the likes are accounted for on those brands and influencers, whereas the rest is with your ordinary people. Of these, half contained an object that was able to identify that image as being part of Splendor. So that doesn't mean contained a classifiable object in the sense of, I can see a car or I can see a dog. That means it contains an artifact which we could then reason that image was taken at Splendor in the Grass. So something like the barn from the Amish barn raising, or this kind of the disco shark, right? That these images, these icons, we know they are part of that Splendor experience. About half contain a classifiable face as well. And of about 90% of those images contained some kind of classifiable object, either a person that could be connected with Splendor or an object that could be connected with Splendor. The point of this is to, I guess, make known how easy it is, even without the geolocative information that you would often get from this kind of social media, that just in the image itself, with no other metadata, you can do this. Right? And this is what I guess made some of this research most potent amongst those in the cultural studies community. It's because most work on Instagram to date had been done just using metadata, right? And the power of the metadata, which is powerful. But just using the image data, you can know all of this. All right, so this is what we're talking about, artifacts which can be identified as being part of that festival site. All of these objects, if I see them, I know that image was taken at Splendor in the Grass in that particular year. Some even more overt than that. The festival stage, signs placed around as well that make it instantly recognizable. Interesting as well for a lot of these, the placement of brands in these. So Cotton On there, this particular brand on these balls, and Smirnoff over there as well. So a number of images also containing recognizable commercial branding inside them as well. All right. So what Nick and I set out to do with this is to embark on what we call the critical simulation of image classification. So we're trying to create in the open space the same kind of architecture that could be used by a large social media platform such as Instagram or Facebook in operating over this data. So try and simulate what is it that they can do with this data? What can be being done? Like, we can't know what's being done with it, but can we simulate what could be done with this image data if in the hands of these? And we argue that we have to develop this capacity. If we're to regulate or respond to this, we need to be informed in how we do that. So we need to actually have a nuanced understanding of the ways in which computers can be reading and operating over this data. All right, so I'm going to flick across now. Yeah. So to the next section, which is more the computational aspect of this. So now you understand the motivation. How do we actually achieve this? So machine vision is a branch of artificial intelligence which deals with how computers can read images and make sense of them. And so there are techniques around like this, mask CNN. So this is basically a deep neural network which you can give it an image, It has a neural network which is trained on a set of images. So it's been given a whole bunch of photographs of the bicycle, and it can now reason within an image what a bicycle is and what it looks like. And so in this image here, it can recognize a bicycle, a person, and a number of other things like that cell phone that lady or that person with long hair is actually holding there. And it can recognize all these objects throughout this image. And it can't just recognize that there is an object such as a person there, it can actually mask it and say it is in this specific location in the image. So you could draw inferences around the location or relationship of these images to each other. This is done using a data-driven approach. So I could ask you, give me a rule to describe the letter A, and you wouldn't be able to do it. Right? The same as you couldn't give me a rule to tell me that that is a chair. Right? This is a task that is learnt and is learnt through experience. So the idea that you cannot train and you cannot give an instruction to a computer to give it a photograph of the letter A and have it work in all circumstances. Right? Because of the infinite variability of the way in which you can write the letter A. Instead, the way we do this with neural networks is to train them on lots and lots of examples of the letter A, because we have not yet got the capacity to express a logic for what makes the letter A. If you disagree, that's fine, like we can have a debate about it later, but it's a difference between we call like bottom up or top down logic. There are a lot of things of which we know what it is, we can recognize it, but we can't express what it is that makes that an A, a B, a C, a D, right? I gave this challenge to my 7-year-old and she came up with a really good response, but still I was able to say, but hang on, what about, right? And so she gets it, right? That point that, yeah, it's difficult and we can't do it in a logic-driven way. And so this leads us to the really, I guess, neural networks. So these were developed back in the 40s. They were developed to try to model the human brain in some way, right? They were an analog to the human brain. The idea that the human brain is made up of neurons and they're connected into these large networks, and we can kind of build an analog to build a computer that kind of resembles the logic of a human brain. And this birthed what we call the connectionism movement. And so this idea that the artificial neuron was a simplification of biological neurons. This theory kind of took hold and many people jumped onto it and started to develop it. So people like Hebb and others started to come up with this as a basis for learning. How do we understand neural networks and how they learn and such? And that started to birth some of the early maths and computer science around this. Rosenblatt actually proposed the first kind of mathematical form of this called the perceptron, and these are still used in neural networks today. The perceptron is the basis of any neural network really in existence. And it kind of looks like this, and it looks really complicated, but it's actually quite simple. What it is you just take a series of inputs, and these might be pixels in an image. So if you take an image and you break it down into a series of pixels, you understand that images are comprised, at least raster images are comprised of pixels that have color and kind of intensity information. If you just take that information of every pixel and you can feed it in here, these networks or these neurons will actually multiply those inputs by a weight, sum them together, and then transform that output to put it between, say, 1 and -1 or 0 and 1. And it does this over successive layers. The reason for this, if you give it different kinds of inputs here, you can expect different outputs on the other end. So if you give it a bunch of pixels representing the letter A, you might expect one value at the output there. But if you give it a series of pixels representing the letter B, those values at the other end of that are going to be slightly different because it's a different set of pixels that are on and off, right? And so you start to get different values at the end of this network. As a result, you can actually train these networks by adjusting these weights and connections to actually make it do certain things, to say, when I give you an A, make the end of that thing 1, right? When I don't give you an A, make it 0. If you've got the right architecture and you've got the right weight settings, you can do that fairly reliably over a series of different kinds of inputs. That's the basics of it. We can go into that a bit more deeply, but I am conscious of time. The way in which we train these things is called backpropagation. So this is an algorithm that actually goes to the end of the network. So you've given it an example and you know what that example is. So you know that's a letter A. You give it that and it says at the end of the network, maybe about 50% sure that that's a letter A. You say, no, it's a letter A, right? Damn it, that is a letter A. And so what you do is you actually move from the end of it and say, well, actually, you got that a bit wrong. I'm going to move through the network and adjust things to make that confidence go up. So you're going to make micro adjustments. It's like if you imagine it like you on a mixing desk, right? And you've got all these little sliders and you're trying to locate the one that makes the sound coming out of the band less crap, right? And so you kind of you're twitching them up a bit more mid, a bit less bass until you find, yep, that's the right sound levels, right? That sounds just about right. It's similar to this, right? In the way in which we're adjusting and twiddling those numbers of that network. And so it does this over multiple cycles, because what you want to do is you want to train it not just to detect the A, but perhaps the letter A, the letter B, the letter C, the letter D. So as you train for one, you often detrain for something else. You're pushing it to learn the A, but it's actually forgetting how to learn what a B looks like. And so there's complex rules in how you do this across, say, lots of images, letters, or whatever it is you're feeding through. All right, so a breakthrough came in doing this because up until that point, these networks were pretty dumb, right? They could only work on very, very limited sets. A breakthrough came in the kind of late 80s. It was called the Convolutional Network. And it solved this kind of challenge here, which it's got reading postcodes. And this system was actually implemented by US Postal to read the the numbers that people put in the zip codes, the 5-digit zip codes on letters being sent across the continental United States. And so, it would read this in and reason that, yeah, that's a 4, and you can actually see it working over it there, right? Guessing correctly, yeah, that's a 9, that's a 1, that's a 2, that's a 3, right? And getting it mostly right. And it's doing exactly that. It's breaking it down to the pixels, feeding them through a network, and that network has learned what is a 4 versus a 5 versus a 3, and so on and so forth. But it did this instead of every single pixel being treated individually. It actually started to extract patterns. It was looking for things like a curve or a straight line, things that connected multiple pixels rather than just individual pixels by themselves, right? And so this is like that next leap forward in terms of reasoning about other kinds of more complex data. Now, I'm going to run through about 20 years of history at this point. Neural networks went massively out of fashion. It turns out, even with this, very difficult to train because you need a lot of data, you need a heap of computation, and these things are really, really finicky to assemble and train and get to work. Massive breakthroughs happen, and essentially the breakthroughs can be summed up like this. To get one of these things working, you need access to a lot of data, right? You also need access to the right configuration, and then also you need massive computation. 3 key factors. The social mobile revolution gives us this, because all of a sudden we're creating a massive amount of things like images and other text and data that can be used. So we create massive troves of data, right? Things like Flickr create huge amounts of images that are all tagged. These can be used as fodder to train neural networks, right? So yes, we have now the data required to train them. Second, academics who've persisted at this, like Geoffrey Hinton in Canada and others, break through a bunch of different more kind of theoretical hurdles in how you start to configure these things. How do we make these things big and able to deal with all this data? And then the third one there, GPUs. The things that drive the graphics on our amazing video games machines, right? Turns out they can be used to build neural networks. There's something about that architecture that involves, like, it's a magnitude of order speed up of training these massive networks. So these 3 things together give us the ability to do this. So this is where we find ourselves now, is in a space where these kinds of configurations, these networks, are being used by the big social platforms. So Facebook recently revealed their older machine learning platforms. So Perceptron is one of theirs, and they implement state-of-the-art object detection algorithms, including this one I showed you just before, Mask RCNN, which is in Python and powered by Caffe2, which is a deep learning framework, right? They release that, and the only reason I would say that a big tech company like that would release something like that is because they already have one that's better than that. Right? So we thought, well, we'll use this one because at least at some point in time they've used it on their own data, but no doubt they've got even more capability and capacity now given other improvements they're making in-house, so their own commercial in confidence. So once again, we can't know, but we can simulate. So I can't know what Facebook are doing. I can't know what Instagram are doing with this data and with their deep neural networks, but we can build something that can try and do this. So what we do is we scrape Instagram using a web scraper. Yes, it's against the terms of service, and we'll get to that in a sec. But these things should be open to public scrutiny. And I would make a strong argument to say, look, a lot of what we do in journalism is also against some laws in some country, but it doesn't stop us, right? Because it's in the public interest. We strongly believe that what we're doing here is in the public interest. So, you know what? Give us an API or we're going to get it some other way. We classify the image objects using this platform, and then we're analyzing the output. So some of what I'm going to show you is early results from this, but I'll talk about where we're taking it. So we use the Reaper platform, which is developed by Adam and us, which is basically you enter. It's really good if you want to do any basic social media data scraping and you're not that cluey about interfacing with APIs and doing all that. It's a really easy to use. I use it with my journalism and communication students at UQ. They all seem to use it well. They're not coders, they can actually generate and download a lot of social media data using this. So yeah, it only hits public spaces. We haven't opened up the Instagram aspect of this just because of what I'm talking about with those T's and C's. I think if we did, Instagram would find a way to shut us out of the system. So it's one of those cat and mouse things at the moment, unfortunately. For those who are techie, we've used the Coco dataset. It's basically an open large-scale object dataset to train all of the images and what they are, and mask RCNN, which I've talked about already. So this is what we get. We had a look at across a bunch of different nightclubs, geolocative tags and such, all on public Instagram. So these are only things you can access without logging in. This is available if you logged onto Instagram right now and didn't put a login, you would be able to get these images. I've still anonymized them by putting faces over the people in these images just to give them some sense of privacy. So this detects two people, detects two wine glasses. It gets this one wrong, cell phone down there. I'll stress here, this is straight out of the box. I have not trained this specifically on this data. It has not been trained specifically on nightlife style data. We've not given it the brands, images, or anything. This is like, basically you've taken a 1-year-old child and said, sort these images into groups for me, right? If we were to dedicate, and that's on the next step of this project, to dedicate time, take photos like this and say, all right, this is that, this is that, this is that, we can expect this performance to actually increase an order of magnitude above what it is now. But still, we're just a naive network. So it's picking cups, glasses, people within this image, other things even in the background. All these people kind of sitting in a row, picking all the drinks, except for one on the end there, it hasn't picked that can out. What's interesting is we know that, say, Pepsi are experimenting this with sentiment. They're scaling across social media at the moment, looking for mentions of Pepsi and making sure people are talking about it in a good way, and harvesting that data as they do, and then targeting their friends and others that they see, say, in the same picture or otherwhere with messages from Pepsi. So yeah, this is kind of the stuff that's happening, and I guess we're just trying to show how it happens. This one's interesting because this is the kind of thing that eventually I imagine we'll be able to pick out those specific brands on those bottles there quite easily. Distinctive branding for a neural network to pick it out is pretty easy. The ones at the back there, all those bottles lined up, they are all bottles. And if I was to show you the original of this, you barely pick that there's a bottle there, but they can find them and detect them very, very easily. Other ones as well, all the objects on the table are able to be recognized, including all the people there. And this one here, I'm interested in this one actually because once again, objects in the background, even objects in the fridge there are able to be picked up. The tops of these cocktail shape, like the spirit bottles, are picked out as bottles as well. So very easy to actually detect these objects and associate them and build, reasoning around this. So yeah, so as I said, what next? We want to train this network on our own data, alcohol brands and other paraphernalia, and other kinds of data like this, right? Figure out what can brands be doing with this, right? We know that these companies are doing things like facial scanning and face recognition, but what else can be done around brands and brand recognition within these, and how easily can that be done? And potentially, likely is it that they're doing it then perhaps. We also want to develop an unsupervised model. So this is done by training saying this is a bottle, this is a can. You can also do this in an unsupervised way where it says just ask the computer, how would you split it? And that can produce interesting results as well. And continue the discussion versus APIs versus scraping. The APIs have been shut down. A lot of academics like me are pretty pissed off about that because on one hand, it's kind of like saying to the public, yeah, we value your privacy, but it's shutting them away from any kind of reasonable scrutiny by us being able to get in there, take images and kind of scrutinize practices that are happening within the platforms. So there's an ongoing discussion there about, I guess, the ethics of scraping versus API access as well.